Good morning, everybody, and I just start my video, and so that you can see what I look like if you need to pick me out in a police lineup. But off it goes now, and welcome. I'm going to share my screen, and off we go. So, an introduction to peering. So, here's a service provider. And a service provider has customers, so we've got the customers along the bottom. And a service provider is usually allocated an IP block from one of the regional internet registries. And for us in Europe, that regional internet registry will be RIPE. But that, of course, depends on where you are in the world. So an ISP gets allocated an IP block from RIPE, and then it can distribute pieces of that to its customers to be able to use. If they've got public-facing servers, they might need public IP addresses, and they can give those public IP addresses from the portion that they get from their service provider. That means that the service provider, if he's advertising to the world using BGP, will simply advertise out using BGP to the world its single IP block. So that single IP block will be an aggregation, and that will be an aggregation of all its customers. And when you are advertising your prefixes to the world, you should always try to aggregate. It's polite BGP peering manners, and it keeps the routing tables short. So here we have the ISP, and there's its IP block, and it can allocate that IP block to its customer, and it would be maybe allocating a /23. And then the customer can take that /23, and you can see it's split it into two 24s. And this customer has two gateways to the ISP. And so if you've got two gateways, you might like to manipulate traffic flow. So you can use BGP relationship with the provider, and you can get traffic coming the correct way depending on what you advertise into the provider. But the key thing to know is that if you're using BGP, multiple gateways are usually needed to have any effect, and you can influence the flow of traffic. Using BGP, you can influence the flow of traffic. So there it is. BGP service provider advertises an aggregate block out to the world, but it can allocate pieces of that block to its customers. Now, that would be called PA, and PA stands here for provider aggregatable. So they're only aggregatable. They're only getting a piece of the provider's aggregated block. And that's because they are customers of that provider. So provider aggregatable. Now, you know that you can influence BGP decision making. I'd refer you back to our last session. We talked about local preference, and we talked about shortest AS path. We talked about MEDs, and we did talk a little bit about local weight on the device as well. So you can influence the way traffic flows significantly with how you advertise your blocks to the world. Now, here we've got a couple of ISPs, and now we've got a customer, and now the customer has two gateways to different service providers. So if you've got two gateways to different providers, then that means you need a public autonomous system number. So 2 gateways to different providers, you will need a public autonomous system number to allow you to do that. Now, if you've just got 2 gateways to the same provider, you can have a private autonomous system number, and that's not registered in the world. Nobody knows it. It's just between you and your provider. But if you've got 2 gateways to the outside world, to different providers, you will need a public autonomous system number. Now, if you are an autonomous system, then you can have BGP relationships with other autonomous systems. And this is very convenient for you to advertise to the world your prefixes. So we can imagine here that this AS number 5 here is advertising, say there is down here network A. So they can advertise network A up using BGP. They can advertise network A to AS1. And now AS1 can send traffic, knows how to route traffic to that network. Now, is AS1 going to advertise network A through to AS2? Well, if it does that, if it advertises network A through to AS2, then AS2 now thinks that it can route traffic through AS1 all the way to get to network A. Now that AS is now carrying traffic for AS2 all the way to AS5. So that would be now performing what we call transit. And transit is carrying traffic into you and out of you on behalf of another customer. So AS1 is performing transit for AS2 because it's carrying its traffic all the way through and out the other side. Now, transit is usually a service, and the kind of the negative thing about transit is it's paid for. So that's a paid for service. And you have to have an agreement with a transit provider. And then the transit provider will advertise networks to you, so you know you can use them to get to those networks. If you're not a transit provider, then you might like to still have a BGP relationship with another autonomous system, just so that you can exchange traffic. So if we look at autonomous system number 4 down here, then autonomous system number 4 could have network B, and autonomous system number 3 could have network C. And there are customers of autonomous system 3, and there are customers of autonomous system 4. Now, autonomous system 4 might like to advertise network B. Now, network B is its own network, and its customers will have portions of that network to facilitate their public-facing services. AS4 advertises network B to AS3, and now AS3 has the capability of getting to network B across that link. Now, this is a mutually beneficial arrangement. So AS3 is going to advertise to AS4 network C. So now customers of AS4 have the ability to send traffic and get to customers of AS3. So you now see that AS4 is advertising its own IP block to AS3. AS3 is advertising its own IP block to AS4. Now this is called peering. Generally, peering, you advertise your own IP blocks and they advertise their own IP blocks, and it allows you to exchange your customers' traffic, and often peering is done for free. So transit is paid for, whereas peering is usually free, and it's a mutual exchange of traffic. So you have to be careful when you're doing your BGP that if somebody tells you about a network and you advertise it out the other side, you might inadvertently turn yourself into a transit provider. So that's why paying attention to what you advertise is vital when you're setting up BGP arrangements with other autonomous systems. Now, you will know, of course, that with BGP, it must be explicitly configured. So BGP doesn't discover other autonomous systems. You have to explicitly say, oh, I want to have a BGP relationship with that other autonomous system number, and you must give the autonomous system number and the IP address of the neighbor to be able to get your BGP session up. And they do likewise, and then you'll get a two-way BGP session. Now, all these autonomous system numbers, they like to exchange traffic. It makes life good for them. It keeps their customers happy because their customers can reach the world. Now, where do they actually go to do this? Well, if they happen to be in the same location, they can just get a cable between their routers and they can exchange the traffic. But often this is not the case. And so there exist these convenient places called internet exchanges. And an internet exchange is where autonomous system numbers come together. And what does the internet exchange give you? It gives you a layer 2 network. Really, it just gives you a switch. So this is an internet exchange. And what does an internet exchange give you? It just gives you a layer 2 network. So you get a layer 2 service, which means that you can now send traffic to other autonomous system numbers. So you can now, your customers can now send traffic through you, through the internet exchange, to another autonomous system and get to their customers. And so we now have a central place where everybody can send their data traffic through a central layer 2 network. And that's what an internet exchange provides for you. Now, when you think about these internet exchanges, there are many internet exchanges all around the world. And so you can go to an internet exchange and you can then create BGP peering relationships with other ISPs in your area. Now, that would allow you to exchange traffic with the local region or maybe a bit further around. Now, if you want to get your traffic to the rest of the world in a different continent, then you're going to have to engage the services of a transit provider. Now, transit providers will turn up at internet exchanges. They may not go over the layer 2 infrastructure, but they might give you a private interconnection in the same location. And that means that we have these transit providers. So this is a transit provider. And this transit provider we would call Tier 1. And why do we call it Tier 1? We call it Tier 1 because it has a global network. And that means that you, as an ISP here, if you're an ISP, you can now allow your customers' traffic to go through you into the transit provider. And that transit provider will allow your customers to reach all locations around the world. But you're going to pay that transit provider. Now, you will need, using BGP, to advertise to the transit provider your networks. So you will have a BGP relationship, and you will have to advertise your networks into the transit provider. And then the transit provider, using BGP, will advertise your networks to the outside world, so that the outside world can also send traffic back to you. And that's the role of a transit provider. Now, this is a Tier 1 transit provider. You can get Tier 2 ISP service providers, and Tier 2 might only be regional, and they might not give you global reach. So we've got Tier 1, we've got Tier 2, and we've got Tier 3. Now, Tier 1, these are going to be transit providers, so they give you a transit network, and they will provide a transit service to you, and you pay them to take your traffic. With Tier 2, we're going down to regional providers, and then for Tier 3, we're going down to what you might call local or access providers, who then deal with the customer. Now, the thing is that your Tier 3 may pay for transit from the regional provider. The regional providers may pay for transit from the Tier 1 global providers. But one thing the Tier 1 global providers never do is they never pay for transit. They will only peer with other transit Tier 1 providers. So this is kind of a map of the internet, and you can see that at the core we've got the Tier 1s, and then you've got the Tier 2s and the Tier 3s, and we hope that traffic successfully flows from customers into Tier 3, Tier 2, Tier 1, maybe peer with another Tier 1, down to Tier 2, Tier 3, and goes to another customer. And traffic should flow efficiently. Now, you can see that what we really want is our traffic to come from a customer, go up, across Tier 1, and then down like that. Now, if you're not careful and you get your BGP advertisements wrong, you can end up with traffic going up, down, up, down, up. Now, people don't want this to happen, and this is called valley routing. And valley routing should be avoided, and everybody should get their advertisements correct, so that the traffic goes up the hierarchy and down the hierarchy, and we get efficient flow of traffic over the internet structures. So transit is a service. Transit is paid for. And transit is the carriage, it's carrying traffic. Peering, now peering is usually free, and it's usually just an exchange of traffic. And peering is usually between providers of equal size. Now, I have to say that you can also say that peering is paid for sometimes. Now, peering can also just mean generally exchanging BGP information. So sometimes, people will say, I'm peering with them. They might just mean they're just exchanging BGP information. So going back to the Internet Exchange. With the Internet Exchange, this now gives you the option of having a BGP session with another autonomous system. Now, when you get to this Internet Exchange, you might like to use that facility. You can then use that BGP session to advertise your network to the world. But other people are there, and so you might like to have multiple BGP sessions because you want to advertise your network to everybody because you're exchanging traffic. Now you can see you've now got 3 relationships of BGP, and if everybody did the same, they would have lots of BGP relationships as well, and all of a sudden you see we've got lots and lots of BGP relationships. And it means that the configuration on your router now becomes more complex because you're maintaining multiple BGP relationships. Now, when you get to an Internet Exchange, they're going to give you the services of a root server. Now, a root server acts as a central distribution point for you to be able to have only a single BGP session. So you have a single BGP session with the root server. The root server has single BGP sessions with other autonomous systems. Now, this is an eBGP session, so the root server does need an autonomous system number. Now, if you go to Lynx, the autonomous system number is 8714. So you will open up a BGP session with the root server. Then you can advertise using BGP. You can advertise your network. So you can advertise network A in a BGP update, and that update goes into the BGP root server. Now, inside that update, you do, of course, give your next hop. Now, that next hop will be this IP address here, and that will be an IP address that's been allocated to you by Lynx. So you advertise your network, you advertise the next hop, and you send that to the BGP root server. Now, who does the BGP root server advertise your network to? Well, you have to tell it, and you tell it by adding on a community. So you add on communities. And what are communities? Communities, BGP communities, are simply root labels or tags. And you can add them to your prefixes, and they can indicate to other people some information. So you can add a community, and you could add a community that effectively says, tell only ASN 64502. So that update comes out of you, goes into the root server, the root server sees the community, and your network will be advertised only out to that particular autonomous system number. Now, the key thing to understand is this is an eBGP session, and you know that you will have, when you send a BGP update, you do have an AS path. The AS path would be yourself. Now, the root server does not add its own AS number into the path. Also, it does not change the next hop. So the next hop stays as the original IP address on the router, and the AS path does not include the root server's AS number. So that means that we can now exchange traffic. These communities, here is an example of a BGP update, and there's a community added on to a prefix. So the prefix lives in there, that's the IP network, and we've added on a community. Now, Lynx publicly declare their communities. They say, okay, if you want to block announcement of a route to a particular peer, you add on the community 0 with the peer's autonomous system number. So this is publicly available information. So you can see if you want to announce a route to a certain peer, it's 8714 peer autonomous system number. So you add on that community. So if you look at this example here, what if we added both these communities to a single IP prefix that we are advertising to the root server? Well, 8714.64502 is an announcement of a route to a certain peer. So our prefix would be announced to 64502. But then you see we've also added 08714, which means block announcement of a route to all peers. So this here would advertise prefix. So this is going to advertise the prefix to the autonomous system number 64502. And this here is going to block to all others. And we've used this in combination, so we're guaranteeing it gets to one of them, but doesn't get to the others. Now, when you use these communities, they are read kind of in this list from top to bottom. It's a bit like an access control list. If you're used to Cisco access control lists, they read from top to bottom. And so this one here allows the advertisement out to that autonomous system. Then they read on, this blocks it to all others. Now, if you don't add any communities, what will Lynx root server do? The default action is to advertise your prefix to all peers. So if you don't add a community, they tell everybody. So the root server allows you to have multilateral peering. So you can advertise prefixes into the root server. Those prefixes can be advertised out according to the communities you set on the advertised prefix. So when you are using the root server, you must be clear that the BGP root server is only distributing routes. When the data traffic flows, the data traffic flow will be through the Lynx infrastructure, but direct to the next hop advertised. So you must be clear that the BGP root server operates in the control plane and the Lynx infrastructure will forward the traffic in the data plane. Your data traffic does not go through the root server. It's only the BGP updates that go through the root server. Bilateral peering, that's one-to-one. Multilateral peering, one-to-many. And it's the ability to do this is provided by the root server. You can easily do multilateral peering with only one BGP session. You can do bilateral peering, and if you want to, you don't have to use the services of the root server. So you could, if you wanted to, have a direct BGP relationship with somebody else and cut out the root server. That's fine. So it's not obligatory to use the root server. Different names for an IX. There are some different names for internet exchanges. One is a NAP, a network exchange point. Then you can have a metropolitan exchange point, and you can have a metropolitan area exchange. And you may see these network access point. There is a LONNAP in London. So that is an internet exchange, and there are some MXPs around the world. So this is a metropolitan exchange point. And this is a metropolitan area exchange. There are different names for internet exchanges where you can go and do peering. Just in case you're not clear with these, POP is just somewhere where you have kit, you have some physical presence, so you have equipment there, and co-location is shared space for kit with multiple customers. And it's very good, co-location is very good because you can go and live in the same data center as your friends and customers, and that means you can exchange traffic very quickly. Now, Lynx will offer you co-location services, so you can get your kit into the Lynx data center along with everybody else. So they do offer co-location. If you were to do a bit of become a member of Lynx, then it is a membership-based organization. And if you did go there, then you can see for free, you get a 1 gigabit Ethernet port for free as part of your membership fee. It's not really for free, you have to pay the membership fee, but you get a complimentary gigabit port. And then if you're doing exchanging a lot of traffic, you can upgrade your ports, and you can see there the prices depend upon the speed. So you have to pay to be at an internet exchange, but they do offer other services. Now this is very small type, but I've included this because I just want to stress the availability for what they call PI. So you've got PI there. PI is private interconnect. Now, you don't have to use the Lynx switches. You can actually go and do co-location in the data center with Lynx, and you can ask them to just set up a cable between you and another autonomous system. So you can have a completely private link from your kit to another kit. And that's a private interconnect. Now, they will obviously, money will need to change hands. You'll have to pay them a little bit of money. Now, that means that that is completely private. you can have your own BGP peering session with another autonomous system, and that's not viewable to the public world, and you have absolute control, and that's purely private link. So that's a service operated by most internet exchanges. You can do private interconnects. So you don't have to use the public layer 2 network. Now, when you go to internet exchanges, they will usually offer you the services of a root server. So here is the root server. Now, what's the point of the root server? Well, the point of the root server is that you can advertise prefixes and they can be distributed out to others. So it's the central distribution point of advertisements. And it allows you just only to have one BGP session instead of having many. Now, when you go to Lynx, and if you become a member of Lynx, then there is this other thing called a root collector. Now, it is obligatory when you sign the Memorandum of Understanding, the MOU, it is obligatory for you to peer with the root collector. But the root collector is a one-way session only. So you can advertise prefixes into the root collector, and everybody is obliged to a peer with the root collector, but it never advertises out. So there's the root server. The root server, you can advertise into the root server and they will distribute out according to the communities that you've added. The root collector, you have a session in and that's all that happens. Now, what's the point of the root collector? Well, just to reiterate, this is mandatory. At Lynx, it's mandatory to peer with the root collector. And one of the things they use it for is they use it to check you are alive according to BGP. And they can also use it for statistics and gathering information about which routes that you're actually advertising. So that's the difference between a root server and a root collector. Root collector you advertise in, and if your BGP session goes down, then Lynx will believe that you've gone down and your router's having problems and they'll contact you. This is a mandatory peering session and they will chase you if you don't do it. I mean, they're not going to get violent, but they will keep harassing you saying, can you please make sure that you peer with the root collector, because it helps them with troubleshooting, because if they get complaints from their customers that you're unreachable, they look at their root collector and say, oh yes, well, their session's down, so they've got a problem. So it helps them in their services. Good. So that's what happens at an internet exchange. You advertise networks to other autonomous systems because you either want to exchange traffic for free, which is peering, or you may be getting the services of a transit provider who's going to carry traffic to the outside world for you. Now, when you do this peering, it's very, very important that you understand the role of the internet routing registries. Now, the regional internet registries, well, these are under the authority of IANA. We have the regional internet registries. So RIPE is the one for Europe, but we've got Afrinic, Asia Pacific, North America, and Latin America and the Caribbean. And what do? Well, they are the central control for IP blocks and autonomous system numbers. So IANA distribute IP blocks and autonomous system numbers to the regional internet registries. The regional internet registries distribute IP blocks and autonomous system numbers to the local internet registries. Now, when we say local internet registries, we're really talking about service providers, and they can distribute things to their customers. So that's just what I've just said. IP addresses, version 6, can do other things. Now, RIPE run a network coordination center, and this is where they organize the distribution of these assets. They also run, and this is key point, they also run a database. Now, this database is actually an internet routing registry, which is part of the database. And they also run, RIPE also run a DNS root server for DNS. And because it's a kind of a public body, they're a great source of information. So they've got a lot of technical information. If you go to RIPE, they will give you lots of information on how to do things. So here we've got RIPE. RIPE gets its IP blocks from IANA. So these IP blocks will have come from IANA. They then give portions of their IP blocks to the local internet registries, and they give them to their customers. And we see PA there, provider aggregatable. Now that's provider aggregatable because it's a piece of the provider's block, and when the provider advertises it, they aggregate it together. Now you do see down here, we've got PI. Now what is PI? Well, PI is provider independent. And it looks here as if you can get provider independent addresses from RIPE. So this means that those addresses belong to you. So if you change your provider, you take the same addresses with you because they belong to you personally. Whereas the problem with provider aggregatable assignments is if you change provider, you have to change IP addresses because the IP block came from the provider and stays with the provider. If you get provider independent IP addresses, those addresses can be registered to you and they stay with you no matter who you're using as a provider. Everybody really wants PI. Now, how do you become a RIPE member? Well, obviously you just go to their websites and you click on this button, join RIPE. What are they going to ask you for? Well, just to join RIPE, they're going to ask you to kind of prove who you are legally. They're going to ask for some money information, and they're going to ask for names and emails. And if you supply that, then you can become a member of RIPE. And of course, there's always a bit of money. So there is this charge that you have to pay every year, and then there's a sign-up fee too to become a member of RIPE. Once you become a member of RIPE, you can do things that are really useful, such as request IP addresses and autonomous system numbers. And also, you can then do registrations in the RIPE database. So once you've got an account, you can then go into the RIPE database and you can create objects. So in this database, everything is an object. So here's the list of the most important objects: ortnum, AS set, root, and route 6. Now, once you get into the database, you must create a person object. Now, this person object is going to be needed to create the other objects. So we've got a person object, which is given identifier. That's called the NIC handle, is their identifier. And once you've got a person object, when you create these entries in the RIPE database, you will see that every entry has a maintainer. And the maintainer is the person who maintains, creates, edits these objects in the RIPE database. And that maintainer will ultimately go down to a person or an email address that you can contact. So what's the point of this database? Why is it so important? Well, you can register your autonomous system number. So this AUTNUM object in the database shows your autonomous system number. And with that, you'll get an autonomous system number, there'll be a name, and very importantly, there will be the possibility of you to declare to the world your routing policy. And when we say routing policy, what do we mean? We really mean what I'm using BGP to advertise or accept from others. So you're basically saying, I'm going to advertise this, and from these other autonomous systems, I'm going to accept these prefixes into me. And you can publicly declare that. And that's routing policy, and that's used a lot by automated systems to check validity and to configure, automatically configure BGP routers with filtering. And we'll talk about filtering later. There's a route object in the database. What's that doing? Well, the thing that really important thing that that is doing, it's taking an IP version 4 network prefix and it's associating it with an autonomous system number. So you can go into the database, look up a prefix and find which autonomous system number owns that prefix. And that's very important, as you'll see later on. And this here, a route 6, well, that's just associating an IP version 6 prefix with an autonomous system number. So we know who owns that IP version 6 network. And now the last one is an AS set. This is just a group of autonomous system numbers. And we'll see why that is important later on. Now, one thing that they make clear when you join RIPE, one thing they make clear is, and it's, I didn't stress it, but it's here on this screen, they say that we have run out of IP version 4 addresses. However, if they happen to find a /24, you can, only if you're a brand new service provider, you can get on a waiting list for a /24 IP version 4 network block. But you have to be a brand new service provider. Existing service providers can't get them, and you can get on a waiting list. And to show you, here is the waiting list, and it's not very long at the moment, or in May, didn't seem to have anybody on it, but that's perhaps because they're going to other places to get IP version 4 addresses, such as an address broker. You can buy them if you need them. One thing you can do as a right member is you can request an autonomous system number. But if you request an autonomous system number, then you must already have an IP range, and you must have 2 peering partners ready to peer with. So you must know at least 2 autonomous systems who are willing to have BGP peering with you. And you need to have your routing policy. And it says routing policy in RPSL format, and we'll talk about that in just a second. So here is the RIPE database, and you can query the RIPE database. So you can put in an IP range into the RIPE database, and it will come back and it will tell you any details. So here I've just gone to the RIPE database and I've typed into the query AS199599, and it's come back and it's found for me an object. And that object is an autonomous system number object. And it tells me that that autonomous system number has a name, Polar Lake. Here is the maintainer. So these are the people who can edit. And you can see it's maintained by RIPE. So RIPE allocated this autonomous system number to this organization. So RIPE created this object, but it can be also maintained by Bloomberg Polar Lake. They can do some editing, but they can't destroy it because it's an autonomous system that's been assigned by RIPE. And what did I tell you? Here is that very important thing. This is routing policy. And this is saying from certain autonomous system numbers, I will accept any prefixes. To this autonomous system number, I will announce prefixes belonging to my autonomous system. So this information can be used by automatic systems to configure filters. So if you get this wrong, and people are using automated systems when they're peering with you, then it won't go successfully. So you have to, it's very polite of you to update this accurately. So you can search the RIPE database for autonomous system numbers. You can actually say, okay, I'm going to do an inverse query. I want everything that has an origin with that AS number. And the key thing here is when we're talking about origin, we're usually looking for these root objects. So in the RIPE database, this is a root object, which I described earlier. I said, what is a root object? Well, a root object is very important. It gives us a prefix and who the origin AS number is, because this is telling us who owns that IP prefix. So this IP prefix here should be advertised. So the origin for that IP prefix should be that AS number. This means that when you get a BGP update, so if you get a BGP update, now a BGP update has a prefix, so you will see the prefix 185.10.116.0/24 in the BGP update. But with every BGP update, they have an AS path. And the AS path lists all the ASs you need to get to there. Well, the origin, which means the last AS, the first AS in the path should be 199.5.1. 559. So this entry in the RIPE Internet Routing Registry is telling everybody that whenever you receive an update for this prefix, the rightmost AS number, the origin AS, should be 199.559. And if you see something different, then you can be suspicious about that update. So this is why these entries in the Internet Routing Registry are vital for people to validate that whoever's advertising that originally actually owns that prefix. You can search on IP addresses and they'll tell you, okay, that's the IP block. So an INET num is an IP block that's been assigned to a provider, and then they can actually use those IP blocks and create root objects. Now, you don't have to create root objects with all of that IP block. It only says that you've been assigned that IP block. Here, lots of information in the RIPE database. Now, I've talked about that, so that's all been done. This is for IP version 6. So here we're talking about IP version 6. And the big thing that you can see is that you can get PI for IP version 6, but you have to have a sponsoring provider who will update the databases for you. Now, this RPSL, Routing Policy Specification Language, the RIPE database is written in RPSL. When you look at it, what you'll see is that you get an object. So you get an object, and then you get these key. So here are the keys here. So there are the keys, and each key is going to have some kind of value. And here is the value. So all objects in the RIPE database are written in this RPSL where you've got keys and values, and that means they can be searched by automated systems, which can do automated configuration based on the information. Now, I've just done a search in the RIPE database in the Internet Routing Registry, and I've looked for this organization name, and it's come up, and it's an autonomous system number, AS9156, and it's called BBC Transit. Now, we have here the routing policy. So it's saying from this autonomous system number, we are accepting any routes, and we give them a local preference of 70. To this autonomous system number, we are announcing, and here is, this is, because it's got AS at the beginning, this is an AS set. This is a group of autonomous system numbers. So this autonomous system number is declaring that when they're having a BGP relationship with this autonomous system number, they are announcing prefixes from a group of autonomous systems. So if you're announcing prefixes to the world on behalf of other autonomous systems, you have to have those autonomous systems in the AS set. So the situation is this. If we have AS, AS2 and AS3, and they are advertising into AS1 like this, and then AS1 is advertising out its own networks, network 1, but it's also advertising network 2 and network 3. But when you look at the AS path on those advertisements, the AS path only has AS 1. So it's indicating that this is the origin, when really those networks do not belong to that autonomous system. Those networks actually belong to different autonomous systems. Now, if these autonomous systems have put entries into the Internet routing registries, so if this has been entered into an Internet routing registry, and they've gone into the routing registry and they said, okay, we're autonomous system number 2, and we own network 2. So that means that anybody receiving this advertisement here and can see it looks, oh, network 3, it's originated from AS1. But when I look in the database, I see that's wrong. So they would drop that. They may drop that advertisement and saying, hey, you're not allowed to advertise yourself as the origin because that network belongs to ASN2. So to get around this, what does AS1 do? AS1 itself goes into the Internet routing registry, and creates an AS set and says, okay, I'm advertising on behalf of an AS set, and it adds into the AS set ASN itself. It will usually add itself, ASN1, ASN2, ASN3, and if that is an officially registered AS set that belongs to ASN1, then receivers of the update from ASN1 can see that ASN1 is advertising on behalf of ASN2 and ASN3. So when they see network 2, network 3 with an origin of 1, they're happy to do this. Now, if you go to Lynx and you're a provider at Lynx and you're advertising networks that do not belong to you, you better get your AS set correct, because Lynx will look at the AS sets, and if you haven't got your AS set in the Internet Routing Registry correct, Lynx will refuse your route. And many exchanges will refuse your routes, and many peers will refuse your routes if you haven't got your AS sets correct. Good. Now, these Internet Routing Registries, there is RIPE. So when we're talking about Internet Routing Registries, so the IRRs, Internet Routing Registries, the IRRs, what are they? They're databases of routing information used for your BGP sessions. You'll find that the regional Internet registries, so you will get all your regional Internet registries, so RIPE and ARIN, LACNIC, AFRINIC, and APNIC. You'll probably find they're running Internet Routing Registries. But there are also some independent ones. There is RADB, and there is Peering DB. There may be others, but those are the big ones. And people, it is true that there's no central Internet Routing Registry at the moment. They're kind of working on it. So you might have to interrogate a number of Internet Routing Registries before you find the information you need. There is no central Internet Routing Registry at the moment. But you can interrogate them using automated systems. You can use whois commands. You can get things scripted. So you can automate your systems. So here's RADB. There's an AS set because it begins AS. So this is an AS set, and this is an AS set for Netflix, and Netflix are declaring an AS set with 3 members. Here is peering DB. I've gone in and I've done a search on the AS number 2818. So this is the BBC 2818. And in peering DB, it's very useful because it does give you all the places where you can go and you can peer with the BBC if you want to. There's LUNNAP, Lynx. Very importantly, it does give you a link for the peering policy. So if you want to peer with the BBC, then you can go here and you get to this page and it says, okay, we'll peer with anybody as long as it's beneficial to both of us. But they do say, okay, if we're going over 1 gigabits of traffic, then we're going to have to go to private peering using some kind of private interconnect, and we'll have to negotiate that. So these internet routing registries, if you're thinking of peering with people, you can go to peering DB, find out where the locations they peer at, maybe look at their peering policies and find information that's going to help you. You can see that their general policy here is open. So they're open to peering. You might find here that they're closed or restricted, and which means that really they're not interested. Good. I think here it might be a good idea if we have a break. So let's have a 5-minute break, allow you just to nip to a comfort zone. I'm just going to do the same. So let's come back here in about 5 minutes. Welcome back after that little break. Now, let's continue. We were talking about the internet routing registries, and if you're going to do peering, you really need to get your details correctly registered in the internet routing registries. Now, I did say that one of the things you can do is you can declare your routing policy, and you can write that routing policy in a standard format, and that format that we saw is RPSL, and you can say what you're importing from which AS numbers and what you're exporting to which AS numbers. Now, if we just have a look at an example of that, if we were to think, and I have to give here a big shout to the RIPE Academy. I've just stolen their diagram here. If you really want to understand how to use the RIPE database, please go to the RIPE Academy, do their free online course. They say it takes 16 hours, but if you're used to networking, it'd probably take you a lot less. And it really does cement how to use the RIPE database and the internet routing registry and how to create objects and get your details correct. Now, if we were to look at this and we think, okay, if we're going to, in the internet routing registry in the RIPE database, what are we going to write? Well, we're going to take the point of view of autonomous system number 1. If we are autonomous system number 1, then we're peering with autonomous system number 4. So that means we're going to be advertising to them our own blocks and our customers' blocks, and they should be advertising to us their blocks only. So we might say, okay, we will import from AS4, we will accept only AS4's prefixes because we're peering. And then we might say, oh, well, export to AS4. Well, we want to announce to them our own blocks, so all prefixes belonging to AS1, and all prefixes belonging to our downstream customers because we're serving them as well. So we will announce AS3. So that's what we would declare when talking about our BGP relationship with AS4. But we do have a BGP relationship with an upstream provider and a downstream provider. So we can say, okay, if we're thinking about the relationship down here, what would we import? Well, we can declare to the world that from AS3, we are accepting prefixes that belong to AS3. But what are we telling AS3 about? Well, we are going to export using BGP to AS3. Well, we're the transit provider for AS3. The only way they get to the world is through us. So we've got to announce to them the keyword any. Anything that we know about, we will announce to them to help them get to the outside world. So what about the relationship with AS2? Well, they are our transit provider. So we're going to import from them AS2. We're going to accept, because they're our transit provider, any route that they know about. Now, what are we going to export? What are we going to use BGP to tell them about? Well, to AS2, we are going to announce, well, we're certainly going to announce our own blocks. So we're going to announce ourselves so that the world knows how to get to us. But we're also going to announce our customers so that the world knows how to get to our customers. Now, some of you might think, well, why don't we announce AS4 as well? Well, if we announced AS4, we've just turned ourselves into a transit for AS4, because now people in AS2, their customers, know they can get to AS4 through us. So we have then made ourselves into a transit provider, but we're only doing peering with AS4. So that would be inappropriate. So we wouldn't do AS4 as an announcement. And so we can now update this in our autonomous system number object in the right database. And if autonomous system number 2 is configuring filters on their BGP relationship, they know exactly what we're advertising to them, and they can configure their filters accordingly. And that goes for our peers and our downstream customers. So this routing policy is important because automated systems are using it for filtering and setting up BGP filters. So if you get it wrong, you might find that things aren't working as they should do. Now let's have a quick chat about route filtering. It is very, very important. So we see this diagram here. We've got a BGP relationship going. So we've got BGP working here, external BGP. What kind of routes are we definitely going to set up a filter so that we do not advertise? So on our outgoing BGP, we want to set a filter up. And what do we never want to advertise to the outside world? Well, we never want to advertise RFC 1918 addresses. These are the reserved private networks that you all know about. 192 and 10 and 172.16, those. So we better put a filter on just to make sure that we don't advertise them. Now, you want to also be filtering BGP prefixes being advertised to you. You cannot assume that they know how to do their job correctly, so you also want to filter incoming any RFC 1980 addresses. You also want to filter out special addresses, such as 127 loopback, other reserved addresses that are specially used for certain situations. So you want to configure a filter to spot those if they're coming in and to drop them. We're in a bit of a peering relationship here. So we will have our peer neighbors advertising networks into us. We definitely want to make sure on our filter that we filter out our peers' networks, because if we don't, we'll turn into a transit provider. We don't want anybody upstream to advertise into us our own blocks. So on your incoming BGP sessions, our own IP blocks should be filtered out because they're internal to us. So there are a lot of things that you can automatically configure BGP filters to filter out. And it's good practice to do reserved special addresses, filter out the peer networks going out, filter out your own blocks, own IP blocks coming in. These are some of the things you should be filtering for: multicasts, experimentals, the loopback ranges. You should be filtering these. Now, people will often refer to bogons and Martians, and you should be filtering bogons. So you should be filtering the bogons going out, and you should be filtering the bogons going in. Now, what are the bogons? Well, the bogons are just unallocated IP blocks or special addresses. Some people refer to the special addresses as Martians and the unallocated blocks as bogons. Generally, if you just say bogons and Martians, nobody gets too confused, but generally bogons as everything unallocated IP blocks. So those IP blocks have never been allocated by RIPE, or they've never been allocated by IANA or any of the regional internet registries. So nobody should be advertising them, so you've got to filter them out. Now, you can get lists of these that you should be filtering. So in RADB, there's a filter Martian. They give all these special addresses. You can use this in an automated system to configure filters. What about the bogons? Well, you can use bogon services, and you can use HTTP. For example, Team Cymru, they do a lovely service of, you can go to them, open an HTTP page, list of unallocated IP blocks. You can also, this Team Cymru, they run a bogon server, which is just a BGP root server, and you can have a multi-hop BGP session with them, and they'll advertise to you unallocated blocks, and you can then bring them into your automated systems to configure filters on your BGP speakers. We've talked about root collectors, so we've talked about root servers, and There are these things called BGP looking glasses, and they will give you a view into the root collector or the root server. And you can find these all around the world. So that, say that you were in the EU, and here's little old you, and you're advertising to the world. You've got some peers and you've got some transit providers, and you're advertising out using BGP. You're advertising out your network. And you want people to be able to get to your network. Well, latency and path length might be important to you. So you might like to see what's happening in America with your networks. So you can maybe go to an internet exchange in America, and they are there sitting at an internet exchange in America. They've got lots of routers, and they're running some kind of root server, and the root servers are seeing what the routers know. And that allows you, if they're running a looking glass, the looking glass is a way for you as an administrator over here to probably use something like Telnet. And you can do a Telnet session, and you can see in to the root collector or the root server. So you can see if anybody in America is advertising network A, and you can see what the details and the path is for network A. So if American customers are complaining that they can't reach your services because the routing is not correct, you can go into the root collectors and see actually, well, what is being advertised in this internet exchange? Why can't my customers get to me? So it spots filters and misconfigurations. And they also offer things like traceroute and ping, so you can ping to your networks. So if we have a look at one, so one of the most famous one is root views. And it's very easy to go to root views, and you just establish a connection with them. And here they are, root views. And they even give you the details to use to log in. And here I am. And I can do a show IP BGP, and I can do 185.10.116.0/24. And I can see who's advertising that in Oregon into the root views server in Oregon in the United States. And it says it's not in the table because I've got the number wrong, and that should be 185, and that was not correct, and that's not correct. Typing's going crazy here, do apologize. And here we go, there we go, 5. So it's being advertised, you see, this prefix is being advertised with this AS path. Now you can see the origin AS is 199.559. Now I'd be happy with that, because I do know when we looked in the RIPE database, I do know that that is officially owned. We did see in here, we can see that that prefix is owned by that autonomous system number, so they should be the origin AS when we see adverts for that prefix. And lo and behold, when we see an advertisement in Oregon for that prefix, the origin is correct. Now this is a longer path, but the origin is correct. Now let's just look at the best path. And you can see here is the prefix, the quickest path, 2 ASs, origin's correct, And notice that there are some labels on here. And with communities, very typically, this is the autonomous system which did the labeling or produced the labels. And that's 3356, which is level 3 transit provider. So if I wanted to find out what that community means, what would I do? Well, of course, I would go to the RIPE database and I would type in that AS number. So we'll do AS 3356. Here it is. It is level 3. And I can show the entire object. And it's got lots of remarks and it's telling you about all their policies and what they're doing. Now, if I look in here, they've got lots of lists of communities. So I'd like to look for that community 33562. So if I do a find on 33562, you can see they've labeled that as a European route. So these labels, these community labels, can be very informative when you're looking in route collectors and route servers to see where they picked up that route. And we've got 2080 here. So let's see why they applied that community label. So let's go to 2080. And you can see they've picked it up in Dublin. So they've just put that community label on there to tell you that that route was picked up by them in Dublin. It was in Europe. And here it is being advertised into a route server, route collector in Oregon in the United States. And that makes sense because this is a worldwide transit provider and this is a Dublin-based autonomous system. So you would expect that to be a good low latency path. So if I were this autonomous system owning this prefix, I would be happy with that result because I probably have a contract with level 3 to do my transit. And that seems to be the best path through my transit provider. So that's the beauty of these route servers and route collectors. The last thing I want to talk about today is RPKI. Now, RPKI is another way for people to feel and know that that advertisement of a prefix is correct. And it stands for resource PKI. And PKI is public key infrastructure. Now, some people might recognize PKI as being used as a security mechanism when you're surfing and you're doing HTTPS connections. PKI is going to be used there. Now, what are we trying to do with PKI? RPKI is if we receive an advertisement in BGP and they're announcing to us a prefix. Now, when we look at the AS path that is announced with that prefix, and we go to the rightmost AS number, which will be the origin AS, we want to know, is that true when thinking about the origin? So was the first autonomous system to advertise that prefix, was it the owner of that prefix? And can we guarantee it? And that's what RPKI is trying to do. Now, with RPKI, it uses public-private key encryption. So we have the two-key method. So there's the private key. And we do have a public key. So there's the public key. Now, these keys were generated together. So this is a key pair. And they were generated together and can only be used together. And the golden rule is lock with one key must unlock with the other. So that means if you lock with the private key, the only key that unlocks is the public key. And if you lock with the public key, the only key that unlocks is the private key. So generally, we keep the private key private. The public key is truly public, and we'll give it to anybody. Now, we need to distribute that key to people who want it because they're going to unlock things that we have locked. So we distribute it in a standard format, and that public key will be contained inside a file which follows a standard format, and that would be an X509, and it is a certificate. Now, I'm sure you've all had certificate warnings when you've been surfing the internet, and that means that they cannot verify that the public key is true. So that's the public-private key method. Now, this is what we're using with RPKI. So what happens with RPKI? Well, the regional internet registry, so for me, that's going to be RIPE. They're running a database. So they're running the RPKI service, and they've got a database. And inside that database, they've got lots of these things. And these are called ROAs. That is a root, origin, authentication. So an ROA has inside it an autonomous system number, the prefix they own with the prefix length, and the maximum prefix length they're allowed to advertise from that block. So how do we authenticate it? Well, we have this thing called a hash algorithm. And we take the data, we take the pure ROA, and we put it into the hash algorithm. And the hash algorithm will produce for us a hash value. So this is the hash value. Hash values are always a fixed length. No matter how much data you put in, the hash value is always a fixed length. Using the hash value, you cannot reverse engineer the data. So we've got our hash value, and we then take, now the RIPE, who are running the database, they will possess a private key, and they will possess, of course, their public key. And they will distribute their public key to anybody who wants it inside an certificate. So you can download from RIPE the public certificate. So what do RIPE do? RIPE take the ROA, put it in the hasher, come up with the hash value. They then take their private key and they lock, encrypt the hash value. they do not encrypt the ROA. That is public information. Why should we encrypt it? That should be somewhere in an internet routing registry. So they take the ROA, put it in the hasher, produce the hash value, take the private key, lock the hash value, and now we have an ROA with an encrypted hash value. What happens now? Well, so the system is, what we'll have is, here's you down here. You can download from RIPE or any of the other internet routing registries. So I can this is the internet routing registry, and you can download from all the internet routing registries. You download from them the ROAs. Each ROA has a locked hash value. So you download the ROAs and you download the public certificate. And you store these on a machine that is called your local validator. Now, the local validator, this is going to be probably a Linux server, and you can install some software on it to make it an RPKI validator, and that freely available open source software is called Routinator. So you will use a protocol such as rsync to synchronize and download all the ROAs from the databases held by the IRRs. What happens then? Well, they download the ROA with the locked hash. Once they've downloaded it, they take the data inside. So they take this data, they put it into the hasher. So that goes into the hash algorithm, which is the same hash algorithm that they used originally, which produces a hash value. They then take RIPE's public key, they unlock the encrypted hash value to produce the original hash value. If the newly calculated hash value on the information they received is the same as the original hash value that was calculated when they made the information, we know that nothing has changed during download. So if they are equal, ROA is genuine, because the only thing that we could use to unlock the hash was the RIPE public key. This guarantees that the hash was locked with the RIPE private key. So we now have an ROA that has been authenticated by RIPE. So we've now got a local validator. And inside that local validator, there is a cache of validated ROAs. If we now have a BGP router, which has a BGP session, and they receive in some kind of prefix, they will look at the AS path. They will look for the rightmost AS number. They are looking for the origin. So they're going to look for the origin AS. Now this BGP router has synchronized with the local validator, so it also has a local cache of validated ROAs. So when the prefix advertisement comes in, this BGP router looks at the origin AS, goes into its cache, it finds the origin AS and prefix and sees if that is the true origin AS. So it's a way of validating origin ASs and making sure that nobody's advertising them in too specific a length. Now, not everybody's using RPKI. So when the prefix comes in and the BGP router looks at the origin, it may look in the cache and it might not find an entry. It may look in the cache and find an entry that's not the same as the origin AS, and that it then knows that that's an invalid advertisement. Or it may look into the cache, find an ROA which matches the prefix and the origin, and it then believes, okay, that's validated, I will accept it. So RPKI is a way for you to authentically validate that whoever advertised the prefix originally did own that prefix, and that's RPKI. Just here is, there are publicly available validators. Here's one. And here I've gone to that public validator. I've put in an IP prefix with an autonomous system number, and it comes back with a very simple reply, just says it's valid. There you go. It may come back with not found, or it may come back with invalid. And it's for you to configure your BGP router, how you act accordingly. Just one thing I will quickly stress, that this communication between the BGP router and the local validator is not BGP. That'll be done through something like TCP SSH or something like that. Quickly moving on, I'm nearly at the end. Just about links, just about going to an internet exchange. What I like to point out is that when you go to an internet exchange, they're going to give you a connection, a port in a switch. And you can only use one MAC address. So you can't be sending frames with multiple source MAC addresses. You get one MAC address that's allowed. If they find you originating frames with different MAC addresses, they'll close you down. The other thing that I want to tell you is, when you go first to an internet exchange, they will put you in a quarantine network and first see that you're correctly peering with the root collector and that you're not sending any traffic that you shouldn't be sending. And only when they've verified that you're behaving correctly will they make you live on the peering VLAN. So they do say that they are going to be looking. So when you're looking at the frames, they're going to be looking at the frame types, and you're only allowed to have frame types of IP version 4, IP version 6, or ARP. Any others, you should not be sending any other Ethernet frame types. And if they pick up on that when you're in the quarantine VLAN, they'll say, we're finding this, can you please disable this? Because routers, they often have things automatically enabled, like link aggregation control protocols and STP and something like that. So they're just checking that you are following their technical principles. So that you all will go into a quarantine before they let you go live. If you want to look at statistics, Lynx is a very open organization. You can go in there, you can get lots of statistics, and you can go into their looking glasses. So here's a looking glass. I did a search on currently my favorite prefix, and I found it being, this was in a root collector, and I found it being advertised by 4 different autonomous system numbers. And there you see 3356, which we did find in Oregon was also advertising the same prefix. So things do make sense. And I think, to be honest, that's all I have time for. I hope you've enjoyed my little wander through peering. If you are going to peer, I really do stress the importance of getting your BGP configured correctly and getting your internet routing registry objects updated and correct. Because at Lynx, if you're not in the routing registry, you're just not going to be accepted. Okay, Holly, over to you.